Hi, so this is a pencast for Physics 6C, problem 38 on homework 1. The problem reads, what is the force on the 5 nanocoulomb charge in the figure? Give your answer as a magnitude and an angle measured counterclockwise or clockwise from the positive x-axis. So let's just start by labeling some of our knowns. So we have our 5 nanocoulomb charge. We're going to label that as Q1. We're going to let the 10 nanocoulomb charge equals Q2, negative 10 we're going to let equal Q3. The 3 centimeter distance is going to be R from 2 to 3. The distance from R to 1 to R12 will be the 4 centimeters. And the distance between Q1 and Q3 will be R13, and that's going to be through here. Okay, let's just start putting our knowns over here. So we want to solve for f on 1. And the angle measured. So we'll let that equal theta. So like I said, Q1 is going to be equal to 5 nanocoulombs. Q2 is going to be 10 nanocoulombs. And Q3 will equal negative 10 nanocoulombs. R12 is the 4 centimeter length. R from Q2 to Q3 is 3 centimeters. And R13 is unknown at this time. And so we know that we can find R13 using the Pythagorean theorem. So R13 equals square root parentheses R12 squared plus R23 squared. And so we're trying to find the force on Q1. So F on 1 will equal, vector addition. So we're just going to do force 2 on 1 plus force 3 on 1. So over here we're going to go to our diagram. So F2 on 1 is going to be going down, and that's because it's going to repel this positive charge. 2 likes repel. F3 on 1 is going to go towards the negative charge. And so if you do the vector addition, your F on 1, your force on 1 is going to be going in this direction. So I'm going to let this angle here equal theta, and this angle here equal this symbol. And the keynote on F3 on 1 is that you have to divide it into x and y vectors. So this will be F3 on 1 in the x direction, and this will be F3 on 1 in the y direction. And so let's just solve for F2 on 1 first. So we know that this force is going to be equal to the k constant times the 2 charges divided by the distance between those 2 charges squared. So k, and these are the absolute values. And remember that it's going to be away from Q2 because it's going to repel that positive charge. So let's just plug in our values. We know that K equals 9 times 10 to the 9th newtons meters squared divided by coulombs squared. You multiply by those charges, so 5 nanocoulombs. We know that if you convert nanocoulombs to coulombs, it's 10 times -9, or to the -9th. And same thing for the 10 charge, 10 nanocoulombs charge. And you divide it by the R distance, which was the 4 centimeters, so 4 times 10 to the -2 meters squared. And if you calculate this out, it should come out to 2.81 times 10 to the -4 newtons. And remember that this is in the negative y direction, so we're going to use the negative j for vector form. So now let's solve for F3 It's going to be the same formula as before, just different inputs. So K, absolute value K1, absolute value K3, divided by R13 squared. And this is going to be towards Q3 because it's going to go towards that negative charge. So let's just input our values. K, 9 times 10 to the 9th newtons meters squared divided by coulomb squared. Same thing, input our charges. And our distance is different this time. So we know through the Pythagorean theorem that R13 is going to be 5 centimeters because it's going to be a 3, 4, 5 triangle. So 5 times 10 to the -2 meters squared. And this comes out to 1.80 times 10 to the -4 newtons. You have to remember that we divided up the force 3 on 1 into x and y vectors. So you have to remember that you're going to multiply this value by cosine theta I hat plus sine theta j hat. So what does theta equal? So we're just going to do the tangent function. So tangent theta equals 4 centimeters divided by 3 centimeters. So it's y over x. Tangent equals y over x. So 4 on this side, 3. And we get that theta equals tangent inverse of 4/3. And this comes out to 53.13 degrees. So we're just going to input this theta into our function right over here. So you have 1.80 times 10 to the -4 newtons. And then cosine 53.13 degrees I hat plus sine 53.13 degrees j hat. And if you multiply this out, you're going to get 1.08 I hat plus 1.44 j hat times 10 to the -4 newtons. So you now have your two forces that are going to combine to get the force on 1. So let's add these together now. So the force on 1 is going to equal, so we only have one I hat number value, so it's just going to be 1.08 times 10 to the -4 I hat. And so remember that we had a -2.81 up here, and then we have a positive 1.44. So you're going to combine these to get minus 1.37 times 10 to the -4 j hat newtons. And this makes sense because our f on 1 is going in the downward y direction. So in order to get the value right here, we're just going to use the Pythagorean theorem. So square root 1.08 times 10 to the negative 4 newtons squared plus 1.37 times 10 to the negative 4 newtons squared. Now if you calculate this out, it's going to come out to 1.7 times 10 to negative 4 newtons. And this is our force on 1. So what force on the 5 nanocoulomb charge? 1.7 times 10 to negative 4 newtons. Now we have to figure out what this degree measure is. So we're going to tangent this angle equals y over x, so 1.37 times 10 to the negative 4 newtons divided by 1.08 times 10 to the negative 4 newtons. And so same thing as up here, we're going to do the tangent inverse, so we get the angle equals 52 degrees, and this will be below the positive x-axis, or clockwise. So